Alright, just a little brief work on the calculator. Your calculators only have 2 logs on them. I'll show them to you right now. Alright, one is right here, and one is right here. One is called log, and one is called natural log. Log is called common log. So every time you see log, it really means log base 10. And it's probably because most of our number system is base 10. Now, natural log, alright, I'll write it over here. Natural log is a base of e, so it's really the exact same thing as log base e. We just decide to write it ln instead of log base e. So we use this quite a lot, and that's why it's there. So natural log is log base e. Well, it wants to find all of these. So let's think through these, right? It wants us to find the log of 13 and the natural log of 13. All right, remember this is, I'm writing it in. It's not going to be there. Log base 10 of 13. Well, 10 to what power is 13? Well, 10 to the first power is 1, and 10 to the second power is 100, so it's somewhere in between there. Here we go. We're going to say, let me clear this stuff out. We're going to say the log of 13. I'm guessing about, I don't know, 1.1-ish? Looks like it. Looks like we're about 1.14. 1.114. The natural log, really, that's really log base e. So it's less than 3, but 3 goes into 13 at least 3 times, right? So I'm thinking about 3. So let's try it. The natural log of 13. Well, maybe not. 2.56. So 2.56. There it is. Let's do the same thing over here. I'm just going to do the log base 10 of 0.42. It's a decimal. I probably get a negative log. So here we go. Right here we're going to say log of 0.42. Negative 3.77. About approximately negative 0.377. And the natural log of 0.42 will also be a negative log base e. So we'll say natural log of 0.42 gives us about negative 8.68, negative 0.868, and we're done with that. Alright, we're going to go down to these word problems. Some of them are kind of easy, some of them aren't. Alright, there's a standard scientific formula that involves logarithms, and these have it. It's for the activity level of pH of a water and the intensity of sound. It's possible to develop your own models involving logarithms by finding the inverse of exponential growth and decay models. But they give us one. All right. The acidity level of pH is given by this formula, where H positive is the concentration of moles per liter of hydrogen and ions in liquid. In a typical chlorinated swimming pool, the concentration of hydrogen ions range from here to here. Range between those two values. So I think it just wants us to, what is the range of the pH for the typical swimming pool? So it just wants us to plug these in, right? So the pH value ranges between two things, right? We could say the log of 1 over, and we're putting this hydrogen in here. So we'll start with the big one here. Well, it doesn't actually seem to be the big one. So we got what? We got 6.33 times 10 to the negative 8. Right? And the other one, pH, is going to be log of 1, and then we're just plugging this in down there. What is that? 1.58 times 10 to the negative 8. There it is. So if I do this, right, if I do this, we're going to get an approximate log of, I don't know, let's put that in there. So I'll clear this out, make it so I can see it here. We'll go 6.37, is that right? I think so. Oh, it's 3.1, isn't it? Should have put a 1 there. 6.31, I put a 3 here, so I'll go back and put that a 1. 6.3, ooh. 6.31 times 10 raised to the negative 8 power gives me that number, which I'm going to move over 8 places, because that's a negative 8. So I'm going to get this. I'm going to get the log of 630. That's 2 places, so I'm going to have to add 6 more zeros. So So 1, 2, 3, 4, 5, 6. Boom, boom. And I get something like that, which I can go ahead and stick in the calculator. So, oh, that's under 1. I just dealt with that. So it's really that. And we're going to say 1 divided by that. So 1 divided by the answer is that number right there. And I'm going to estimate that is about 15,800,000. So we're going to get the log of about 15,800,000 just to estimate right there. And so I found that this number, divided it into 1, and I got that. And now we're going to get the log of that. So I'm going to say log second answer. If you're curious, that puts the last answer in right there. Second answer. I hit enter. It looks like it's going to take, well, looks like that's about 7.2. So approximately 7.2. That's the pH value of a swimming pool. At least one end of it. Let's get the other end. We'll do this all at once now. So here we go. I'm going to stick that whole thing in there. That is 1 divided by, I'll put in parentheses, 1.58 times 10. Was that negative 8 power? To the negative 8 power. Like that. See what it gives us. Gives us that. I'll just write, what is that, about 63 million? So I'm going to say approximately 63 million. Is that 63? 1, 2, 3, 4, 5, 6. It's about 63 million. Alright. And I'll just put a 0, 0, 0, 0, 0, 0. So a little bit different here, right? 1 was about 15 million when we were done. I did skip a step there. Let's do the log of that. We'll say the log of second answer. I get about 7.8. So approximately 7.8. So the pH of our swimming pool is between 7.2 and 7.8. Now, let's do the hard one. There is a harder one here. Alright. So, I have this last guy down here, and it says the population of a colony of bacteria of 3,500 bacteria at a time in minutes can be modeled with this function. Alright. How long does it take the population to reach this? So, we're going to start off by just writing this as a logarithmic function. Alright, I'm going to take this and I'm going to say, you know what, I've got to solve this. I've got my exponent here and so on, and we're going for it. So, first thing I'm going to do is I'm going to write it. Alright, I'm going to say P equals 3500 to T over 73. And now I'm just going to start peeling stuff away, right? I'm going to divide by 3,500. 3,500 here, 3,500 here. That gives me P divided by 3,500 is equal to 2T to the 73rd power. Alright? And what am I going to do here? I guess I could plug numbers in right now. Let's do it. Let's plug it in. So I'm going to plug in 1,792 right here. So I'm going to go 1792000 divided by 35000 equals 2T to the 73rd. Here we go. And let's see if it's right. So we got 1792000 divided by 35000. Looks like I get about 51.2. Alright. So 51.2 equals 2 to the T over 73. Alright, so what are we going to do now? Let's keep moving just a little bit, I guess. So let's try a log. So what if log base 2 of 51.2 is equal to T to the 73rd. All right. Alright, I was curious what happened there for my decimal. I divided that wrong. So I'm going to keep going. I divided by 35,000 instead of 3,500. So if we look, this is going to be 512 here. Now, this really says, what base of 2 gives me 512? What power of 2? Let's try that. Let's see. 2 to what power equals 512? I think I can probably count that out, right? That's 2, 4, 8, 16, 32, 64, 128, 256, 512. So 2 to the x is really equal to 2 to the 9th power, right? So x is 9. This statement right here is 9 equals t over 73. And then to solve that, I multiply both sides by t. So t is going to equal to 73 times 9. And t is going to equal 657. So that says how long does it take the population to reach that? And I believe it is measured in minutes. I could be wrong. Yeah, it's in minutes. So it's 657 minutes. Now, we're going to do a lot of stuff like this. So if that one kind of hits you a little weird, that is okay. Let's fix this decimal. That decimal doesn't go there. I'm going to erase it. I got 512. And that's it. I'll do a couple of these for you in class. Hopefully that was the hardest part of this, and I'll see you tomorrow.